Hello everyone, this video is for explaining about NLP. NLP stands for Natural Language Processing. NLP is a field of AI that enables machines to understand, interpret and generate human language. So basically NLP is connecting humans and machine. NLP combines linguistics, computer science, machine learning. So it's like we can say that it interdisciplinary field which involves expertise in understanding the languages, linguistics, right, and computer science and machine learning. It's a very important one. So right now everyone is talking about LLMs, right? Large language models like ChatGPT and Gemini. They are basically NLP things, right? Though right now we can straight away use the LLMs in almost all kinds of NLP requirements. It is important to understand the basics. In some use cases, we may need to work with very basic NLP models. So in that perspective, I believe this video is useful. Okay, let me explain the concept, but always we can use straight away use the LLMs for our NLP requirements, right? So first of all, why NLP matters, right? NLP right now powers various tools, especially as I explained, ChatGPT. Not only ChatGPT, all kinds of LLMs like Gemini, DeepSpeak, Q1. All these powerful LLMs are working based on the NLP, right? And translation like Google Translate, that kind of stuff, and voice assistants like Siri, Alexa, and spam filters. Whenever we receive emails into a Gmail, it is automatically if it is receiving spam emails, it is automatically marked as spam and moved into spam folder, right? That kind of features are powered by NLP. And the sentiment analysis, almost all the e-commerce companies are using this kinds of feature, right? By going through the customer review details or any kind of articles, it will be able to classify it as whether it is positive or negative. That kind of sentiment analysis, finding emotions, that kind of things can be done with the help of NLP processing. As I said, it is a powerful thing, combining linguistic, computer science and machine learning. So basically NLP bridges the gap between human communication and machine understanding, right? Though we can straight away use LLMs in almost all kinds of NLP requirements, we need to go through how NLP basically works, right? That will help us to use it in from basic level. In some cases we may need to do that. Let me explain that one by one. Okay. First, let me explain about key NLP tasks. Okay, natural language processing NLP involves these kinds of tasks like tokenization, POS tagging, named entity recognition, NER, sentiment analysis, machine translation, text summarizations. A lot of things are there. I will be just giving some overview about these things. Tokenization, it's a very important process. Even in case of using LLMs, we need to understand that tokenization process so that we can estimate the API usage charges, other things. Okay, so basically tokenization is nothing but breaking the text into words. Okay, words in the sense it's not simple words. It involves a lot of things. It will vary based on the model. Okay, so the tokenization is it's like a bit complex thing only, but simply we can understand that it is breaking the input text into words. Okay, and POS tagging. It is identifying nouns, verbs, and adjectives. That kind of identification. Doing that kind of identification is that POS tagging, part of speech tagging, right? Named entity recognition, NER is like recognizing names and places. Okay, it will be like going through the sentences and identifying the names and person names or organization names and places, location names and dates, any kind of month, day, date, that kind of information. So finding that and tagging it as location, date, person, like that. Okay, it's called as named entity recognition. POS tagging is part of speech, like identifying nouns, verbs, adjectives. So based on dictionary information, it is NER is based on the common understanding of whether it is name or location, like that. Okay. Sentiment analysis is like detecting emotion or tone, right? It is like whether the customer review is positive or negative, that kind of thing. And the machine translation, translating sentences from one language to other, say for example from English to Tamil, right? And this text summarization, like getting the summary of the text, right? These are all the key NLP tasks. As I said, though all these things can be done with simply done with LLMs like ChatGPT and Gemini, we need to pay money to their API usage, or in case if you are going to use local LLM like Llama, Mistral with the help of Olama or Docker, in that case you need to have some technical expertise, and your local computer should be supporting like it should be having powerful GPU, right? That kind of constraints are there in that case. Okay, for basic like in case if you are using some RAG pipeline or chatbot kind of stuff, the main thing we can use with the LLM, right? But for supporting things, say for example, if you are creating one chatbot and like in that chatbot you are using some LLM, say for example you are using Google Gemini's model, and you are paying for that usage. Okay, but for maintaining context history, like if you are keep on sending all the previous questions along with the current questions to the LLM, then you have to pay more for the LLM, right? Because the token usage will be more. In that case, for reducing the token usage, we can get the abstract the keywords from the previous questions, and we can just send the keywords alone or some summary information alone. That kind of things, maybe we can use our own NLP model. We can create based on our own use cases. That will be giving two advantages. One is it will be more effective because it will be fully depending on our own data or our use case, right? So it will be more customized according to our own requirements. Then in that case it will be working better than standard LLMs, and obviously we will be reducing the token charges, the API usage charges of LLMs, right? So though we can directly use LLMs for almost all these use cases, all these tasks, it is better to know how to use NLP simple models and how to integrate with our AI applications. Okay. But I would suggest that straight away you can go with the LLMs if it is possible, if it is a reasonable usage like that. Okay, because they are really powerful. So basic NLP workflow in that case, first thing is text pre-processing, like cleaning the text by removing unwanted tags, other things, and tokenizing, splitting the sentences into words, that kind of stuff, and removing stop words. Like stop words are like the and that kind of words. They are not going to add much value, right? And next thing is feature extraction. It is like TF, IDF is term frequency. IDF stands for inverse document frequency, right? In case of term frequency, it's just counting the number of words in the sentences, and based on that word count, we can decide whether that part of sentence is related to what kind of information. Okay, but in case of IDF, it is like normalizing that. Say for example, it will be considering that occurrence of that words throughout all the entire document, so that we can normalize. Say for example, assume that I have one document telling about trending emerging trends of AI in 2025, right? In that case, assume that I have one paragraph talking about RAG. So in that paragraph, there may be multiple times the word RAG will be coming, right? In that case, say for example, assume that in that paragraph is having the word RAG 4 times, okay? And in the same paragraph, that word 2025 is coming 5 times, right? But the entire document is about 2025. So obviously, it will be coming throughout the document, right? So in that case, we shouldn't consider that that paragraph is talking about 2025. Though the count of 2025 occurrence is more than the count of RAG, that paragraph is more related to RAG, right? Because the entire document is 2025. So in that case, we can just go through all the documents. We have to just scan all entire document, and we can understand that we can just ignore the 2025 part in case of dealing that particular paragraph, right? That kind of things. So it's like keep on improving. But in case of word embeddings, like word to vector, that kind of thing, it is like converting the text into equivalent numerical things, vector, like. Okay, so in that case, it will be giving semantic meaning also. Okay, in case of kingdom, that king and queen are related, right? But in case of mattress, that kind of bedding, that company, they are referring to the size of the bed, right? So in that case, it is related to more related to size instead of relating with the palace, right? So that kind of semantic meaning. So based on the context, that words will be getting different meaning. So that kind of things can be handled effectively with the word embeddings. It will be very useful when we are going to implement RAG, retrieval augmented generation. I already uploaded a detailed video about that. Okay, and modeling, like classification, generation, that kind of stuff, right? Generation is very obvious, that like LLMs, all the LLMs are powerful. Classification, like classifying whether it is spam or not spam, that kind of thing. And evaluation, like whether that NLP model is working properly or not. So for that, we need to find the accuracy, okay, whether it's working properly or not. That evaluation should be done, right? So that is key part of NLP workflow. And deployment in apps. Okay, so NLP, as it is, there is no state usage, right? So we have to effectively use in apps. It can be speech to text, that kind of app, or text to speech. Okay, or translation, like that. We already gone through various use cases of NLP, right? Okay, that kind of applications. Because the workflow is text pre-processing, feature extraction, modeling, evaluation, and deployment. Okay, so as I explained previously, we need not care about all these things if we straight away go with the LLM is it's like one kind of NLP, right? So it's advanced NLP. Straight away we can use that. Okay, in that case, all these things were already done by the companies who created that LLM. So in case of the first step, text pre-processing, a lot of things can be done. The normal process are like lower casing, right? Like converting all the sentences into lower case, and removing punctuation, removing unnecessary comma, semicolon, that kind of punctuations. Removing stop words like the, is, on. Okay, and the tokenization, like converting AA is powerful into AAI is powerful, like that. But it is not always like this. As I explained, each kind of model will be doing in different ways. Okay. But all these things are text pre-processing. So NLP applications, there are various applications like customer support chatbots, resume screening, like automatically screening the resumes based on the recommends. Okay, social media monitoring, whether people are talking about any product like positively or negatively, that kind of information. Healthcare report analysis. Okay, legal document summarization. So mostly chatbots, various chatbots and user assistance kind of applications. Okay, so there are various NLP libraries available so that we can easily do the programming with them. NLTK is a very famous one. Okay, and Spacey also providing NLP activities. Okay, and challenges in NLP, like sarcasm and context, finding those things are a bit difficult in the NLP process, because though we are calling it as AI, artificial intelligence, basically it's not having any kind of intelligence. It's not cognitive. Okay, it's working purely based on text prediction, sequence prediction, that kind of approaches only mostly. Okay, almost all the models are working, all the AI algorithms are working in that way only. For humans, for us, it is very easy to identify whether that sentence is sarcastic or it's a normal one, like that, right? And identifying context also easy for us. But in case of AI, that NLP, they find it difficult to identify sarcasm and context, that kind of things. Okay, and similarly ambiguity in the meaning, and understanding, multilingual understanding, like if the sentence is having words from different natural languages, then identifying them may be a bit difficult. But now like advanced models are using doing that properly, but still it's kind of challenges in NLP, right? And domain specific language. We can easily understand that if you're going through any medical article, pressure means blood pressure, like that we can assume. In case of other like mechanical industry, we can assume that it is about air pressure or something, right? So it's it's based on the domain specific things, right? But anyway, these advanced NLP models are doing that things effectively. But they are not up to human level, right? As I said, the main reason is they are working, their way of working is completely different from our way of cognitive things. Okay, so recent trends, obviously LLMs, like everywhere that LLMs are getting used. So LLMs are very powerful in a industry, and that is one kind of NLP. Okay. And recently people are talking about multilingual models, MBERT, like that. They can effectively handle multiple languages, right? And prompt engineering, it's very important. As I said, LLMs are now powerful because they are trained with a lot of data with the help of huge computing power. So obviously they are really effective. So instead of training our own models, we can straight away use already available LLMs. But for using them effectively, we should know how to use them effectively, right? That is prompt engineering, framing our prompt is very important. Like prompt is nothing but giving query to that LLM, right? It's there are a lot of standard ways of doing that. I already uploaded one detailed video about prompt engineering. Okay, let me show simple examples. Here, this example, I'm using Colab from Google. Here, this particular code is using a pipeline from the transformers library provided by Hugging Face, right? Here pipeline is really useful one. Here we can just give the purpose. We need not specify the model, other things. So it will be automatically finding the relevant models from available with Hugging Face. Okay, and then we can use it for our NLP things. So here I provided very simple examples, but a lot of things can be done with this. Okay, so one simple example is sentiment analysis. It's a very simple thing, right? So we are just importing the pipeline, and we are asking it to use sentiment analysis for sentiment analysis, and we created this classifier by specifying pipeline argument as sentiment analysis. Okay, and here we are providing the input text. I like artificial intelligence, so we are just printing the result. Let us see what is the result. So it is positive, right? The sentence is positive with 99%. Okay, so it is negative with 99%, right? I'm just telling some neutral things. I learn artificial intelligence. So here the positive percentage got reduced, right? 92% only. Okay, so it is sentiment analysis. So we, NLP, that model can get the input text, and it can find the sentiment of that sentence. Okay, here as I said, I haven't mentioned the specific model. Hugging Face, that pipeline automatically used this Distilbert base, this model. BERT model, distilled version of the BERT model. Okay, suppose if we want to use any specific model, here we can provide the model name also, like model like that. If you are going to use any specific model, we can mention the model here. Okay, it's a very powerful thing. Okay, this next example is this classification, and that is zero shot classification. We are not going to give any examples or things. Just by giving the input sentence and labels, it will be able to classify that. Okay, let us check this one. The text is, I recently bought a shirt and it has good designs. Potential labels are technology, fashion, sports. Okay, here we are passing both the text and the labels. Let us see the output. Okay, it has completed the classification, right? We downloaded the record models and related files, right? The sentence is, I recently bought a shirt and it has good designs. Labels are like fashion, technology, sports, right? So it created the score. This sentence is 91% related to fashion, 4% related to technology, and 3% related to sports, right? So obviously it's a fashion related sentence, right? So it classified properly. So this sentence is fashion related thing. Like let me add some other sentence. I would like to buy a laptop. So here it is using the Facebook's bot that model. Okay, as I said, the pipeline will be automatically choosing the appropriate model. Okay, if you are not specifying that model, otherwise we can specify the model. Here it is, the sentences, I would like to buy a laptop, and here it is correctly classified as technology, right? Technology is the score is 98%. Fashion 1% only. Sports 0%, right? So it is zero shot classification. The first one we did sentiment analysis. Okay, the next one is this NER, named entity recognition. Here the text is, Raj founded QPT in 2008, right? It is using this BERT model. Okay, here it's identifying that name, right? Name Raj as person, right? PR, and QPT as like organization. Okay, but it's splitting because it's not a common one. It's just splitting the words p characters itself. But if you use something popular one, it can maybe. I'm just changing the word like sentence into Gates founded Microsoft in 90s. Right? So again, it's using this BERT model. It identified Gates as person. These are all examples for NLP tasks. Okay, but as I explained previously, most of these things we can use simply one LLM model, and we can do everything, right, with the help of prompt itself. But as I said, in case of RAG pipeline or in the AI agents as a supporting things, we may need small NLP models also. Okay. In that case, we have to know how to use them effectively. Okay. Thanks for watching.